Hello everyone, I hope you guys are doing fine. I am your friend Manish and today we are going to discuss one more interesting interview problem. So without any further delay, let's get started. So first of all, we are going to discuss the problem statement. The problem statement is implement a stack by using a queue. So yesterday we discussed a problem which was a vice versa, like we implemented a queue using a stack data structure, and today we are going to discuss how we can implement a stack using the queue data structure. So let's go through the problem. So here it is given that in a JavaScript array, if we use the push and pop method, then it acts as a stack because we are pushing the elements to the end of the array and we are popping from the end of the array itself, right? And if we use the push and the shift method, push is like pushing at the end and shift is like removing element from the start of the array, then it behaves as a queue. And suppose the next given statement is we are given the queue which is available to us as a data structure. That means we can safely use enqueue to insert new element, peek to get the head element, dequeue to remove the head element, and the size to get the total length of the queue, total elements in the queue. So these methods and the data structure is readily available for us to use, and what they want us to solve is implement a stack data structure using this queue, and we cannot make use of the arrays. Cool. So this is a problem statement. We have to implement these methods: push, peek, pop, size. That means by using queue data structure only, we have to push elements at the end and remove elements from the end only. So I hope the problem statement makes sense. Now let's discuss our solution to this problem, and for that we will go to the other screen. Okay, so let's see what stack is. So I select this. So this is 1, 2 and 3. So I can insert the element in the stack and that gets inserted into the stack, and if I want to remove the element, it will be removed from the top only, like it gets inserted here and it gets removed from here only. It's called LIFO, last in and first out. Last in and first out. Sorry, it's getting zoomed in. Okay, cool. So this is something which we want to implement. Now what is given to us is this one. 1, 2, 3 and 4. So here elements gets inserted from the end and gets removed from the head, which is like the element which gets inserted at the very first position at the beginning. Okay, so now what we want is, so given these scenario only where we have 4 elements, right, in the queue, what we want is we want to remove this element. We want to remove the element which is at the end, which is 4. So how we can do that? So if you see clearly, right, what we can do is the elements which are at the start of the queue, right, until we reach the end of the queue, what if we could move those elements to the end of the queue? For example, I can perform a dequeue for 1 and I can insert it at here. So it becomes 1, then 2, right, and then 3. So when all the elements till the before the last element, till we reach the last element of the queue at this position. So okay, let's consider this was our original queue, right? So what we can do is we can make a loop, or we can program in a way that before the last element we can remove all the elements from the queue and insert them back to the end of the queue, so that our last element becomes the first element, so that this becomes the first element, right? And then we can safely do the delete operation on that particular queue at the head of the queue. and that is something which we will be doing. So after moving the elements to the end, our queue will become this, right? So this 4 will become the head of the queue, and then we can safely remove the elements from this queue. And say we remove the basically we remove the element 4. Now say we want to remove the element 3 now. What we will do is we will safely move these two elements at the back, and it will become so here it will become 3, then 1, then 2, right? And then we will safely remove the 3 because it has become the head of the queue. So I hope our solution makes sense, our approach makes sense. Now let's get back to our coding environment and try to implement this. So we are here. So we are going to implement stack, and we have given the queue data structure to use. So let's initialize constructor here, right? And it becomes this dot queue is equal to new queue. So we initialize this, and when we want to insert a new element into the stack, for that we can safely use the queue. So insert is fine, we can keep pushing the element to the queue. Dot enqueue, and this is element, right? And size is also simply to implement whatever the length of the queue, we can simply return that. So this will be this dot queue dot size, which is the reading which is calling this method. So we will get the size of the stack by using this method. Now the peek and the pop, so both the operations are similar, it's just that from pop we are removing the element as well, and here we are only returning the element which is like the head of the queue. Cool. So as we discussed, right, so we need to first find the total elements in the queue. So total, this will give us this dot queue dot size, right? So we get the total number of elements. Now what we have to do is we have to make a loop till total -1, because we have to keep the last element we have to make the last element the head of the queue. We have to make that as the first element of the queue. So what we will do is let count is equal to 0 while count is less than total -1. What we will do is we will pop that element and insert it to the back of the queue. So element is this dot queue dot dequeue. We removed the element from the queue, and what we can do is this dot queue dot enqueue the element, enqueue element, and count plus plus. Cool. So we are done with moving all the elements from the start of the queue till the last element of the queue, because we have to remove the last element from the queue. That way only we will be able to implement the stack, because stack's definition is last in first out. So we have to make our last element as the head of the queue, and this will do that. And lastly, this is peek operation, right? So we will simply return the element using peek method, this dot queue dot peek, right? And in case if queue is empty, sorry, we can use this total only. If there is no total, simply return from here, simply return the undefined. I hope this makes sense. And now we can simply copy paste this to here, because the process remains the same. Get the total number of element, and until we reach the last element in the queue, we will keep removing the elements from the start of the queue and pushing that at the end of the queue. And lastly, we will do the dequeue here. Pop. So the pop is also implemented, and let's try to test it now. Cool. So our solution worked successfully, and all the test cases which they had for the stack implementation are successfully passing. Cool. So that way you can implement a stack using a queue. Cool. So there is one more solution to this particular problem which you can try at your own. I will just discuss that solution here only. So approach remains the same, but these removing the elements and appending them at the back of the queue, we did that in the peek and the pop method. Rather, we can do that at the time of insert as well, right? For example, what we can do is I can check the total length before enqueuing, like before inserting into the queue. What was my total length before, right? Then I did a append operation, enqueue operation, and then I will implement the same loop, right? I will do the same loop here only, so that my last inserted element becomes the head of the queue, right? So that way we can implement the insert time migration of the elements from the start of the queue to the end of the queue. So that is insert time, moving the elements, and this is read or remove time, the moving the elements from start of the queue to the end of the queue. So I hope this makes sense. You got the solution which we implemented here, and if this video you find it helpful, this video helped you in any way to understand the concept and helped you in your learning, then please consider like, share and subscribe to our channel. That gives us a quick motivation and helps us to create more such useful content for you guys. See you soon. Until then, take care. Bye bye.